talked about the various relations as I had given you that home task that how should you relate sine theta and cosecant theta, cos theta and secant theta. Tangent theta was done for you, but cotangent theta was given to you. Let me work it out and let you see that how exactly it works out. We said that sine theta is perpendicular upon hypotenuse, that is AB upon AC. Then you were asked to work out that relationship between the sine theta and cosecant theta, and I had mentioned that you take this perpendicular from numerator to the denominator of denominator, and then what do we get? We get 1 upon hypotenuse upon perpendicular. That means this becomes 1 upon hypotenuse upon perpendicular. This is what was defined as cosecant theta. So this is written as cosecant theta, and if you work it out, that this is AB upon AC, that is sine theta, that was perpendicular upon hypotenuse. What I had done is I had taken this perpendicular to the denominator of denominator. Same way we take this AB to the denominator of denominator, so it becomes 1 upon AC upon AB. And in that last class we had worked it out that AC upon AB, that is hypotenuse upon perpendicular, that is cosecant theta. So since this is in 1 over AC upon AB, this is 1 upon hypotenuse upon perpendicular, this is 1 upon cosecant theta. So that simply means that this is sine theta equal to 1 upon cosecant theta. So this is that relationship. Hopefully this is very much clear. Let me work out the second one. Second one was this base upon hypotenuse. Base is BC divided by hypotenuse, that is AC. We say that this is base upon hypotenuse. Now, taking this base to the denominator of hypotenuse, cos theta. Now, what we did here in this case, sine theta, we have taken that numerator to the denominator of denominator. So same way, we take this BC from numerator to the denominator of denominator. So it becomes 1 upon AC upon BC. That means this is 1 divided by hypotenuse divided by base. And remember that hypotenuse divided by base, that is nothing else but secant theta. So this is 1 divided by sec theta. So combining these two together, we get that cos theta is equal to 1 upon sec theta. This is another relationship. Is that okay? So sine theta is equal to 1 upon cosecant theta, cos theta is equal to 1 upon secant theta. Now, we are going to relate this sine theta and cos theta. In that last class, we had done that relationship. And let me work it out that how exactly was that. Now, in that previous class, we talked about the relationship between sine theta and cos theta is tangent theta. And let us see that this side AB upon BC, side AB upon BC equal to perpendicular upon base. This is what was given to us, and we said that this is equal to tangent theta. We had given one relationship that this tangent theta is equal to sine theta upon cos theta. This was worked out in that last class. Now what we are going to do is we are again going to change this perpendicular from numerator to the denominator of denominator. Then what we get is that this is 1 upon BC upon AB. That means this is 1 divided by base divided by perpendicular. This is equal to 1 divided by, now see that this is base upon perpendicular, not perpendicular upon base. Base upon perpendicular is cotangent theta. So tangent theta can be written as 1 upon cotangent theta. So that becomes our next relationship. Tangent theta is 1 divided by cot theta. So this is it. Is cot theta related in any way to cos theta and sin theta? Let us work that one out as well, and let you compare it with work that you have done and see to it that if you have done it correctly. We had done that BC upon AB, that is base upon perpendicular, is cot theta. As we talked about the relationship between tangent theta and sin theta and cos theta, same way we are going to work out for this cot theta and cot theta as well as sin theta and cos theta. So how is it? This is base upon perpendicular. We bring in the third element, the hypotenuse, in this relationship. What we get is that we may say that this is BC divided by AC and AB divided by AC. We can divide any number by the same expression both in numerator and denominator. That will not make any change. So this is equal to base divided by hypotenuse, and in the denominator part we have perpendicular divided by hypotenuse. Now base upon hypotenuse, that is nothing else but cos theta, and perpendicular upon hypotenuse, that is sin theta. So here we have cot theta equal to cos theta divided by sin theta. And remember that in that previous class we talked about sin theta upon cos theta is equal to tangent theta. That means it is just the reverse way around. Cot theta is the inverse of tangent theta and vice versa. Hopefully it is all clear that whatever relationships are there in between these trigonometric ratios and the relationship between these three sides of the triangle. Mind it that we are not going to have any impact of the size of the perpendicular and the base. Rather, it is the effect of this theta, the angle between the hypotenuse and that base. That is what matters, because as you have studied in that similar triangles, the angles remain the same and then the sides can be made bigger or smaller. That aspect you can even work it out even in your phone or in computer, that whatever aspect is given there, you can make it larger, you can make it smaller as per your wish. So same is the case here. Now angle is given and accordingly you can increase the size of perpendicular or decrease this size, but both perpendicular and base, they will be moved in the same proportion for a given angle. Now to make it clear, let me take up a few examples, just one or two examples, so that it may give you a clear indication. Let us say that you are given a question that sine theta is equal to 5 upon 13. Let us say that you are given this question and then you are asked to find out the value of other trigonometric ratios. Fine. Now, what does it mean? It says that the expression or the value of sine theta, mind you that theta is not given, but the whole trigonometric ratio for this sine theta is given 5 upon 13. And you are asked to find out the values of the similar values of the other trigonometric ratios. So for that, we need to refer back to our basic aspect, that this is dealing with this right angle triangle, and in this right angle triangle the ratio of perpendicular to the hypotenuse, which happens to be the sine theta, that is 5 upon 13. So how are we going to work it out? For this one, we write this solution that we are given sine theta is equal to 5 upon 13. And by definition, we have that this is perpendicular upon hypotenuse. Now, if this is perpendicular upon hypotenuse, this is 5 upon 13, that means perpendicular side is 5, hypotenuse is 13. Now remember Pythagoras theorem. By Pythagoras theorem, we have hypotenuse square equal to base square plus perpendicular square. Now we are going to substitute the values and we get hypotenuse is 13, base we are not having any value here, perpendicular is 5. So we have (13) squares equal to base square plus 5 square. 13 squares, you are having 169, that is equal to base square plus 25. Now we can take this numerical value 25 to the left hand side. It becomes 169 minus 25, that is 144 equal to base square. This gives us the value of the base square, but we want base. Now taking square root on both sides, we get base square and we are taking its square root. This is equal to 144 square root. Base square, square root of base square. Now this square and the square root, they are working opposite to one another, so they get cancelled out. We are left with base only. I hope you know that how to calculate the square root of 144. So square root of 144, that is 12. My dear, this value comes out as plus minus 12, because plus 12 square, that is 12 into 12, that is 144, as well as minus 12 into minus 12, that is 144. But since this base is nothing else but that is some length, base is a length, so that length can never be negative. Therefore, we simply say that this base is 12. Base is 12 units. Nothing like centimeters or meters or kilometers, because this is basically this trigonometric ratio, that is a ratio, and ratio doesn't have any unit. So here we have this base as 12 units. So once we have got that base 12, now let me write here that this base is 12, perpendicular was given to us as 5, and hypotenuse was given to us 13. Now that makes the job much easier now. So after this we simply have to find out the ratios, since we know the definition of various trigonometric ratios. So let us deal with that. Sin theta we have already been given. We go with this cos theta. Cos theta, we have that base BC divided by hypotenuse AC. BC base is 12 and AC hypotenuse is 13. Tangent theta is perpendicular AB upon BC. AB perpendicular is 5 units and base is 12 units. So that is the tangent theta. Now another one, that is cotangent theta. Cotangent theta is 1 upon tangent theta. We can work it out this way as well. That means it is 1 upon 5 divided by 12. 1 upon 5 divided by 12. Now 12 being in the denominator of denominator, so that will go into the numerator. So this becomes 12 upon 5. And even otherwise you can work it out that the definition of cot theta is that this is side BC upon AB. You can say that cot theta is BC upon AB, and that is equal to 12 upon 5, or you may work it out in this manner. Sin theta we were given 5 upon 13. Cosecant theta is 1 divided by sin theta, that is 1 divided by 5 upon 13. We can write it as 13 upon 5. 13 upon 5, that is this hypotenuse AC upon side BAB. Similarly, secant theta. Secant theta is 1 upon cos theta. 1 upon cos theta, that is equal to 1 divided by 12 upon 13. We write it as 13 upon 12. And that is nothing else but side AC upon the base, that is BC. So this way we can, if we are given one trigonometric ratio, we can work out the other trigonometric ratios accordingly. I hope that is clear. Another type of question that can be asked is 13 cos theta equal to 12. 13 cos theta equal to 12. Find out the value of other trigonometric ratios. Now you have to work it out that we are given 13 cos theta is 12. So what is it? We get started with it that 13 cos theta equal to 12. So that means cos theta is equal to 12 upon 13. Cos theta is 12 upon 13. That means it is base upon hypotenuse. This is base upon hypotenuse. Now this, once again, this is giving you the same pattern or same kind of question as we have discussed earlier, that cos theta is base upon hypotenuse and the ratio of the two sides is 12 to 13. So you have this triangle in which the base is 12, hypotenuse is 13, and then you once again you work out by that Pythagoras theorem, you will find out the perpendicular as 5, and then once again you write those definitions and work them out. Hopefully that won't pose any problems to you. If you like this presentation, please like, share, and subscribe, and don't forget to press the bell sign. Have a good day.